Good morning, dear students. In today's class, we'll see the next theorem, Stoke's theorem. In the previous class, we have seen the Green theorem, the statements and the problems based on that. Now, we'll see the Stoke's theorem, its statement and problems. Stoke's theorem statement: if S is a surface bounded by simple closed curve C, and if vector f is any continuously differentiable vector function, then integration of f dot dr, vector f dot dr is nothing but double integration over the surface S of curl of vector f dot n cap ds. So curl of vector f can be written as what here? Del cross vector f dot this n cap ds as it is. So I can say that integration of f dot dr can be stated as double integration over the surface S del cross vector f, which is nothing but curl f dot n cap ds, where this n cap ds is nothing but dy by dz of I plus dz by dx of j plus dx dy of k. Means while writing coefficient of I, you just don't mention dx. While writing the coefficient of j, you don't write dy, and while writing coefficient of k, you don't mention z. So it is dy into dz of I plus dz into dx of j plus dx into dy of k. Now with the help of this statement and the value of n cap ds, so this is a surface n cap ds, we'll see the problems on Stoke's theorem. So we'll see the example. Question is, evaluate vector f is equal to x square plus y square of I minus 2xy of j by Stoke's theorem taken round the rectangle bounded by x is equal to 0, x is equal to a, y is equal to 0, y is equal to b. Now as we know that the given vector f from the question as it is, that is vector f is equal to x square plus y square of I minus 2xy of j I have taken, and we know that dr is nothing but dxi plus dyj plus dzk. So this I have taken f from given question, and dr we know that it is a distance, that is dxi plus dyj plus dzk. Next we have the Stokes theorem as vector f, integration of vector f dot dr is equal to double integration over the surface S del cross vector f, that is curl of vector f dot n cap ds. Now so we'll find first what is vector f dot dr. So vector f dot dr is nothing but, I'll write the vectors for vector f, that is x square plus y square of I minus 2xy of j plus 0 into k, because it is not there I am mentioning 0 dot, and dr, vector dr is nothing but what here? Dxi plus dyj plus dzk, that is dxi plus dyj plus dzk. So dot product of two vectors we'll see now, so which is nothing but I dot I, we need to work out j dot j, k dot k. So coefficient of I is what here? X square y square into dx, minus into plus is minus 2xy into dy, plus into plus is plus, 0 into dz is 0, that's why leave it. So this is our vector f dot dr. So once we got a vector f dot dr, means left hand side we got it, right hand side we need to work out. and this is our vector f. So you see that right hand side we need to simplify for del cross vector f. So now del cross vector f, which is nothing but determinant, means I j k dou by dou x dou by dou y dou by dou z. Coefficient of I from vector f, it is what here, x square plus y square. Coefficient of j from vector f, minus 2xy. Coefficient of k from vector f, there is a no at that time, you may have to mention 0. So on simplification of this vector will be, so we'll simplify, so we'll get this as I times first row, first column you have to hide, dou by dou y of 0 is 0, formula minus dou by dou z of minus 2xy, because no z term, constant, differentiation of constant with respect to z is 0, minus j times first row middle column, dou by dou x of 0 is 0, minus dou by dou z of x square plus y square, no z term, constant, 0 with respect to z, plus k times, so first row last column, dou by dou x of minus 2xy, it will become minus 2y, formula minus dou by dou y of x square plus y square will become 2y. So therefore on simplification we'll get this one as 0i plus 0j, so minus it will become minus 2y minus 2y minus 4y minus 4y plus is nothing but minus 4y of k. This is the value of del cross vector f. So what shall we do now? So we got the answer of del cross vector f. We need to apply that in this Stokes theorem now. So how to apply, we'll see now. Now before applying the integration, so I need to work out for del cross vector f, we know it already, dot, we know that n cap ds, which is nothing but we have 0i, del cross vector f 0i plus 0j minus 4y of vector k, we got as del cross vector f, just now we got the determinant, dot n cap ds is nothing but what here, it is dy dz of I plus dx dz of j plus dx dy of k. Fine. So dot product of again two vectors, so this nothing but 0 into coefficient of I 0, plus into plus is again plus, 0 into j again dx into d again 0, so minus into plus is minus 4y into dx dy, 4y into dx dy. So therefore del cross vector f dot n cap ds result is minus 4y dx dy. Now this is ready to integrate directly now. So by Stokes theorem, so we know that Stokes theorem, so left hand side as per the question it is f dot dr, according to f dot dr it is what here, integration of so left hand side f dot dr, which is already we have calculated in the previous steps, f dot dr, that is because left hand side f dot dr I have taken this value, right hand side we need to apply the value of what here, del cross vector f dot n cap ds, which is also we have calculated now, so which is nothing but how much here, minus 4y dx dy. Now we'll apply the limits for this to integration. So they have instructed in the question itself that the surface is bounded by, the surface means the surface, the S is round the rectangle bounded by x is equal to 0, x is equal to a, y is equal to 0, y is equal to b. So you can draw here a diagram for this. Axis I will draw first, x axis, y axis, this is a, this is b. So this is what here, 0, that is 0 comma 0. So when x is 0, so this is the point, x is a, one more point, y is 0, it will come here only, y is equal to b, it will come here. So if you join it, it will become a rectangle. So based on this, we need to write the integration here, so which is equal to double integration. So x varies from 0 to a, and you draw a strip. So this is a complete surface. X varies from 0 to a and y vary from what here, 0 to b. For minus 4y, first we are going to integrate with respect to y, then with respect to x. So which is nothing but 0 to a, this minus 4 as it is, integration of y with respect to y, what here, it is y square by 2 into dx, limit from 0 to b into dx. So therefore this minus 1, 2 ones are 2 2s are minus 2, I will keep outside, minus 2 integration 0 to a y square, limit from 0 to b into dx, that is minus 2 0 to a, apply upper limit, it will become b square minus 0 square, minus 0 square you leave it into dx. So b square is a constant, so therefore it will be minus 2 times 0 to a b square dx. So b square is a constant, so it will become minus 2 b square, keep as it is, integration of dx is x, limit from 0 to a, that is minus 2b square, apply upper limit, it will become a minus 0, which is nothing but minus 2ab square. So therefore integration over c, x square plus y square into dx minus 2xy into dy is equal to what we got, minus 2ab square using Stoke's theorem.